Hello to all. I am Dr.A.K, Professor of Chemistry. Today I am going to discuss measurement of change in enthalpy and change in internal energy. These two terms, how it is experimentally determined, I am going to discuss. That is change in internal energy means delta U, and change in enthalpy, that is the delta H. How it is determined experimentally. Last class I have discussed relation between Cp and Cv, heat capacity at constant pressure and heat capacity at constant volume, and we have derived Cp minus Cv is equal to R. R means universal gas constant. Cp is always greater than Cv. Always remember, Cp is always greater than Cv. Why? Because here in expansion only this thing in case of Cv, heat capacity at constant volume, that volume change will be there, not Cv. Cv means constant volume. Then volume is constant, then there will be no change in volume. Only whatever temperature is required to raise the temperature of 1 mole of gas by 1 degree. That is actually heat capacity at constant volume. Here only temperature is required to raise the temperature by 1 degree. But in case of Cp, here two work is going to be done. Heat is going to used in two ways. First, that because pressure is constant in Cp, pressure is constant. Then pressure is constant, it means volume may change. Volume may change. Then some heat is required to change in volume. Okay, some heat is required to change in volume, expansion. And after that some heat is required to raise the temperature by 1 degree. Okay, hence more heat is required. That's why at Cp, in heat capacity more heat is required. Cp is greater than Cv. Okay, and one relation already I have told you. Here we will use in measurement of delta H and delta U, that relation you will use, that is equal to delta Cp, delta not Cp, these things, delta U is equal to delta H minus delta N RT. This relation is important here. Okay, delta U is equal to delta H minus delta N RT. Why you have written delta N RT? Because delta U is equal to delta H minus delta, or you can write delta U is equal to delta H minus P into delta V, and minus P into delta V is equal to, that is a delta nRT, because PV is equal to nRT. Then both relations are same type of relation. Okay, PV is equal to nRT from the gas equation, ideal gas equation. Then just if we put the value of PV is equal to this thing nRT, from that PV value, then you will get the relation in term of delta nRT. Then this relation we will use here in the measurement of delta U and delta H. Okay, then here how will you use delta U, means change in internal energy. Then this actually is used by an instrument known as calorimeter. Calorie, CAL, calorie means heat. Calorimeter means measurement of heat. One instrument is there, this name is calorimeter. Then by the use of calorimeter you can measure the delta U, means internal energy. Okay, then here how will you use that I am telling you. We can measure energy change associated with chemical or physical process by an experimental technique called calorimetry. In calorimetry, the process is carried out in a vessel called calorimeter, which is immersed in a known volume of a liquid. Okay, in that you have to immerse that vessel. In that vessel actually reaction will take place, and that vessel you have to dip in or immerse in the, you can say maybe water, okay, warm water. In that water you have to immerse, or water you can keep, not necessary warm water, normal water, in that you have to immerse. Then what will happen during the heat? Suppose a reaction is evolving during the heat, this heat will come out. During the reaction heat will come out, then that heat will go to the surrounding, means water. Then water temperature will increase. Because then you can measure that temperature. One Beckman thermometer will be dipped in the solution. Solution means water. In water, Beckman thermometer will be there. Then you can measure how much, you can say there is an increase in temperature, because initial temperature will be known. Suppose it was not 25 degree. Then now after some times temperature raised. Suppose it become now 25 to 28, 3 degrees suppose raised. It will tell direct delta T value, it will tell T2 minus T1 value. This Beckman thermometer directly tells. Hence delta T value you will easily come to know. And when delta T value you are coming to know, then after that you know that if you are knowing the delta T value, then this both delta T value you are knowing. Then when delta T value you are knowing, then you can know the these things, delta U. Okay. Then here delta U value easily you can determine. Okay, delta H and delta U both are related. I told you delta H is equal to delta U plus delta N RT. And this from the delta U value and delta H value, okay, only both are just getting difference due to the minus delta N RT. Okay, then if you are knowing that delta H, delta U also you can know. Then here actually delta T value if you are knowing, then how will you come to know Q value, means heat? How will measure? Then you know that QV is equal to that is the heat capacity into delta T. Then if you are knowing the heat capacity of the vessel, then that value will be given actually in question. Then this heat capacity is will be given, and delta T value by the Beckman thermometer you will know. Then just both you have to multiply. then delta T into heat capacity, that is equal to Q, that is the QV means heat capacity you are knowing, and that heat capacity is equal to delta U. All things I have discussed. This heat capacity is equal to delta U, okay, and this QV is equal to, I told you, that is equal to delta U, and QV is equal to other relation, that is heat capacity into delta T. Heat capacity into delta T. The delta T value you are knowing. And heat capacity of the instrument means calorimeter, that will be given. Then just you have to multiply, you will get the internal energy. Delta you change in internal energy. That I have told you. Okay. Now just I will brief it with this things instrument. Actually this main things I have told you, but actually minor change will be there, that about the instrument that I am going to tell you. Then process is carried out in a vessel called calorimeter, which is immersed in a known volume of a liquid. Okay. Known volume of liquid, volume of how much liquid we have kept, maybe water, generally water is kept, other liquid also may be kept, and that volume also you might be knowing. Okay, you will know. Then after that, heat capacity of the liquid in which calorimeter is immersed, and the heat capacity of calorimeter. Okay, here what you will come to know, and I told you the process is carried out in a vessel called calorimeter, which is immersed in a known volume of a liquid. Okay, knowing the heat capacity of the liquid in which calorimeter is immersed. Sometimes this calorimeter heat capacity of calorimeter also will be knowing. Sometimes for liquid also it is required. Okay, then this knowing the heat capacity of the liquid in which calorimeter is immersed and the heat capacity of calorimeter, both if you are knowing, then it is possible to determine the heat evolved in the process by measuring temperature change. Okay, measurements are made under two different conditions. At constant volume, that time heat will be called QV, and at constant pressure, that time heat will be called QP. Then delta, suppose you are going to measure the delta. Actually I will discuss these things about the instrument. Okay, the main thing I have already briefed you. Then suppose you are going to do delta U measurement, change in internal energy. Then for chemical reaction, heat absorbed at constant volume is measured in a bomb calorimeter. B-O-M-B, bomb calorimeter. This is made from steel. Okay, here a steel vessel, that is called bomb. A steel vessel that is called bomb is immersed in a water bath. The whole device is called calorimeter. The steel vessel is immersed in water bath to ensure that no heat is lost to the surroundings. Whatever during the reaction heat will evolve, that should go to the water. Okay, the steel vessel is immersed in water bath to ensure that no heat is lost to surroundings. A combustible combustible combustion, it is related to combustion. A combustible substance means reactant. A combustible substance is burnt in the presence of oxygen in the steel bath, because to burn always oxygen is required, hence there will be oxygen supply. Heat evolved during the reaction is transferred to the water around the bomb and its temperature is monitored. Since the bomb calorimeter is sealed, it will be completely sealed. It can't go outside. Directly it will go to the, you can say, through a steel, it will go to the water. Okay. Since the bomb calorimeter is sealed, its volume does not change. Okay. Then obviously it will be QV, no change in volume. Its volume does not change. That is, the energy change associated with reactions are measured at constant volume. Under this condition, no work is done, as the reaction is carried out at constant volume in the bomb calorimeter. Even for reactions involving gases, there is no work done, because gas will not expand, it will not go outside. Okay, hence there is no work done for gases also. That is a delta V is equal to 0. Then temperature change of the calorimeter produced by the completed reaction is then converted to QV by using the known heat capacity of the calorimeter. Okay, with the help, already I have told the equation that QV is equal to heat capacity into delta T. The delta T you are now knowing, and this heat capacity will be also knowing. Okay, then you can calculate the QV, and QV is equal to delta U. Like that way you can know the internal energy, how much during the reaction internal energy is changed, you can measure easily. Okay. Now, how will you determine the delta H? How will you determine? Then here also same instrument will be used, because delta H is related to constant pressure. Then here you have to make the system, in the system pressure must be constant, means you are going to do experiment at atmospheric pressure. Very easy, atmospheric pressure. Then there will be no change in pressure, means existing pressure is called atmospheric pressure. Then it is very easy. Okay, measurement of heat change at constant pressure, okay, generally under atmospheric pressure. Okay, atmospheric pressure can be done in a calorimeter. Already I have told you, it's a diagram I will send you. In the video. Okay, we know that delta H is equal to QP. This relation also I have told you. Delta H is equal to QP and delta U is equal to QB. Okay, all relation I have told you. Then here we will use this only. We know that delta H is equal to QP, means at constant pressure, and therefore heat absorbed or evolved, QP, heat absorbed or heat evolved, both are possible. That is called QP. At constant pressure is also called the heat of reaction or enthalpy of reaction. Okay, both are same. Heat of reaction or enthalpy of reaction, both are same. In an exothermic reaction, already I have told you, experiment is done in the same way. Okay, what we have done in the case of this change in internal energy same way. Here pressure is constant, that is only difference. In an exothermic reaction, heat is evolved and system loses heat to the surroundings. Okay. Exothermic reaction, heat evolves, when heat will go outside. Then in system, heat will be less. That's why here minus sign is given. And delta H always is negative in case of combustion reaction. In case of combustion reaction means burning. If anywhere anything is burning, it means heat is going outside. As for example, wood will burn. Then heat will evolve. Then heat will go outside. Exothermic reaction. Even the anything, if iron also, if it is red heat, then it is releasing heat. Okay. Then their energy will be less. That is also exothermic reaction. In any reaction from where heat is going outside, then it is called exothermic reaction. Okay. Then here at constant pressure, both is possible. Okay. Exothermic reaction, exothermic and endothermic. Endothermic reaction, already I told you, if reaction is not taking place, then you are heating it. Just like you know that in kitchen you are using a stove. Okay, you are using a stove, then you are heating it, then food is going to be cooked. Then that is endothermic reaction. Many, now I given hint you can understand endothermic reaction. If reaction is not taking place, then you are supplying heat. Then here heat is going to be absorbed. Then reaction will take place. Some reaction will not take place simply. You have to heat it. In lab you have seen. Then heating, by the heating means heat is going to be absorbed. You are supplying heat. Then heat is going to be absorbed. Then heat absorption, how much heat it absorbs, that is called, that reaction is called endothermic reaction. Endothermic, E-N-D-O, endothermic reaction. Okay. Then in this reaction both is possible. In an exothermic reaction, heat is evolved and system loses heat to the surrounding in case of exothermic reaction. Therefore Q will be negative. QB will be negative because it went outside. It went outside. And delta which will be also negative. Both are here same. In the case of exothermic reaction, both will have same. Okay, QB will be negative and delta H will also be negative. Similarly, in an endothermic reaction, heat is absorbed. Then QB is positive and delta H will be also positive. Question is asked. Okay, and this sign always you keep in your mind always, that in thermodynamics and in thermochemistry, okay, these things are very, very important, and question is asked in almost all examination, IIT, medical, UPSC, even for this concept is used for the highest level, that is the UGC CSIR net examination. These concepts are very, very useful in different way. In indirectly this concept is useful. Now I am going to tell you these things I want to explain you by a numericals. Because numericals, thermodynamics, full thermodynamics is based on numericals only. Full thermodynamics and thermochemistry. Okay. Thermochemistry is mainly involved with the, you can say, during the reaction heat is absorbed, then in a reaction liquid will be there, solution in the solution form, okay, then solvent will be there. At that time it will be called thermochemistry. Thermochemistry means during the chemistry reaction will take place. Then during the reaction heat is absorbed or heat is heat is evolved or absorbed, that is studies. Name is there, thermochemistry, and generally reaction will take place in solution form. Solvent will be there. Two liquid will mix. Different, you can say, different reagent will mix. Then only then reaction will take place. Then generally in solution form reaction will take place. Then thermochemistry is related to that. Thermodynamics, in that it will apply generally, you can say, for big system, okay, wherever heat is exchanging, just like I told you, thermoflask, from the thermoflask, it is not allowing entry or going outside, but only in a beaker. If you are giving, then it is going outside. Then like that way in thermodynamics is used in a general way. In a general way, thermodynamics is used for big system. Okay, thermochemistry also is used in a big system only, but only relation that is in liquid form generally, that is for reaction, chemical reaction. But thermodynamics is used for any other system also, including this reaction also. Now I am giving one example, numericals. I am question first. I will read long question is there. Again, one more thing I want to tell you, that here numericals will be big only. Okay, it will look big. And all numericals based on thermodynamics or thermochemistry, it will be big only. Hence you have to read the question, and but your solution will be easy. Only question will be big. Okay, don't can say by seeing the question you don't think that it is big question you can't solve. No, you can solve it. You have to understand the question, and solution will be very easy, formula based. Okay, data will be more, because in solving the numericals and formula, you know that many data is required. Now question I am reading you, just to understand. Question first to understand. 1 gram of graphite is burned in a bomb calorimeter in excess of oxygen at 298 Kelvin and 1 atmospheric pressure, according to the equation C plus O2, that is equal to CO2 gas. C is graphite solid. C is graphite plus oxygen. No, that is a gas. Then C plus O2, arrow sign you can give CO2 or equal sign, no problem. Then this reaction they have given, that reaction is going by this reaction takes place according to this reaction they have given. During the reaction, temperature rises from 298 Kelvin to 299. Okay, 1 degree raise the temperature. If the heat capacity of the bomb calorimeter is given 20.7 kilojoule per Kelvin, what is the enthalpy change, delta H, they are asking. What is the enthalpy change for the above reaction at 298 Kelvin and 1 atmospheric pressure? Okay, this they are asking to calculate these things, enthalpy change, only enthalpy change, delta H they are asking to calculate. Then in your mind you should know that how delta H is related. How delta H is related, how will it is related to Q. Then already I have told you relation, that Q is equal to CV into delta T. This relation you are knowing. Q is equal to CV into delta T at constant volume. Okay, this is the relation. Then quantity of heat from the reaction, will have the same magnitude but opposite sign because of heat lost by the system. Here automatically system is losing the heat because carbon will burn in bomb calorimeter, then automatically it will lose the heat, hence minus sign will come. Okay. Then here you are knowing Cv value they have given, heat capacity value they have given, and temperature change. Already you know only 1 degree change temperature change from 298 to 299 means formula you can usually use Q is equal to Cv into delta T. But here Cv will be minus because system is losing the temperature. That's why minus term you have to use, minus sign. Then minus sign minus Cv into delta T. Cv value is given. And delta T also you are knowing 299 minus 298 Kelvin. Okay. Then what will only 1 degree change. Then it will be minus 27 kilojoule into 1. That is the same things, 20.7 kilojoule. Okay. Then now this Q value you are knowing. It means what? Here this value you calculated Q value, then enthalpy change, delta H only you have to calculate, then Q value you are knowing, then you are actually reached to the answer actually. Then here only for 1 mole you have to calculate because you have calculated only for 1 gram. Okay, 1 gram, this heat it lost by 1 gram. Okay, whatever 20 they have given question 20.7 kilojoule per Kelvin, that is for 1 gram. Then for 1 mole you have to consider carbon 1 mole, this is carbon 1 gram, then 12 gram carbon means 1 mole carbon. Correct? 12 gram carbon means 1 mole carbon. Then for 1 gram, minus 20.7 gram heat is coming out from 1 gram. Then from 12 gram, just to simply multiply 12 into minus 20.7 kilojoule. Then you will get what? That you will get value you will get after multiplying, you will get these things 2.48 into 10 to the power 2 kilojoule per mole, 2.48. Actually 12 into 20, that is minus 20, then it will come how much? Very simple, 12 into 240. Okay, just simply in a general way 240 will come, but here you are taking in a 10 to the power 2, then you can write minus 2.48 into 10 to the power 2 kilojoule per mole. This is the exact way because 20.7 is there. Then if you will multiply, then exact result will be minus 2.48 into 10 to the power 2 kilojoule per mole. And then here you know relation, you know that this is only Q value calculated, Q, keep in mind. Then you have to correlate with delta H. Then you know that delta H is equal to delta U, or you can write, you already told you delta U is equal to delta H. Correct? Delta U is equal to delta H minus you can say delta N RT. But you know that delta N in this case change in volume is equal to nothing. Okay, 0. Delta N no change in mole, only 1 mole is there, you calculated only for 1 mole, no change in mole, delta N value is 0, hence this term delta N RT will be 0. Then now you calculated very simply that delta H in this case delta H is equal to delta E U, delta H is equal to delta U, both are same, and delta H, already told you formula that delta H is equal to this thing QV, it is delta H is equal to QV, already told you both are same, and QV is equal to heat capacity into delta T. Okay, then heat capacity QV you calculated delta QV into delta T. Delta T was only 298 minus 299 minus 298 1. Okay, this formula you have applied. Hence, QV you calculated that QV is equal to delta H. But you are also, you can know delta U also, because both are related. Okay, here there is no change, delta n value is equal to 0, and so when delta n is 0, then by the relation delta H is equal to delta U minus delta n RT. Okay, that for one more, when there is no expansion of gas, then you can calculate these things also. No, here del PV is equal to nRT, na? Then here whatever we change is there, delta V, then that is equal to nRT. Okay, but here PV is equal to nRT. Relation is simply P into delta V is equal to nRT, because pressure is constant and volume may take change, volume change may take place. Okay, but here it is not related, in this question not related to change in volume, we are not considering that things. Okay, but change in volume will be there. Then whatever way, P into delta is equal to nRT. N is here 0, n is 0, that's why delta is equal to delta U minus delta nRT. For then here delta n is equal to 0, and the delta is equal to delta U also, and delta H already you calculated, delta is equal to that is Q. Okay, delta is equal to QV, delta is equal to QV. Okay, and QV is equal to delta T into heat capacity. Okay, like that way you have calculated. Today I am stopping only here, and next class we will meet with you can say so many terms are there, all terms are very very important, full of conceptual, and now for every terms numericals will be asked. Okay, and completely mathematical, and that I will ask. Different terms are there, many terms are there, small terms are there, and full of conceptual. Thermodynamics is full of conceptual. Okay, not theoretical, it is mathematical, full, and numericals is asked. Then now in next class again I will discuss that new terms, many terms are there. Okay, thank you.